My name is Jack Montoya, and this is Physics 2211, Lab 5. In this lab, I will go over the purpose of the lab, some important concepts, my glow script model, and then conclude with some results and questions. This experiment was to find the kinetic friction between a quarter and the floor of my dorm. I used the work energy principle, and my glow script model uses kinematics to track the motion. On the right, you can see a video of the coin sliding down a frictionless slope onto the floor, which has friction. The concepts I used in this lab were the work energy principle, the position update formula, the formula to find friction force, and the velocity update formula. For this experiment, with the measurements I took during the experiment and manipulating some of the equations, I was able to solve for the coefficient of kinetic friction. I started with the work energy principle, and using the work done by friction and plugging in the formula for the friction force, I was able to solve for the kinetic coefficient of kinetic friction based on the height that the coin starts at on the frictionless slope and the distance the coin travels once it reaches the bottom of the slope. Glow script model, I set the initial conditions of the system, including the mass of the coin, which I found from the internet, the delta y and delta x that I measured based on my reference video, and the velocity of the coin using the energy principle, because the coin starts with potential energy and ends with just kinetic energy. In the loop of the glow script model, the coin is modeled where the net force done on the coin is just the friction force. This model also just shows the coin's motion when it reaches the bottom of the incline to when it comes to rest. So inside the loop, there's also the velocity update formula to update velocity, and then the position update formula to update the position. So the results that I found was that through the tracker and my reference video, I was able to deduce that the change in displacement for the coin once it reached the bottom of the ramp was 0.599 meters, and I used that delta x to solve for the coefficient of friction, and then when I modeled the kinematics with the coefficient of kinetic friction that I calculated, the glow script model that I created gave me a delta x of 0.574 meters. Some errors that could account for this difference in values include that I assumed the incline was frictionless, even though it isn't actually frictionless. It's close, but it's not completely frictionless. And there could be some measurement errors where I'm using the tracker measuring tape. The coin was rolling as opposed to sliding, well then the friction force would be static friction, which is what would cause the coin to roll, and I would need to account for rotational kinetic energy as well when using the energy principle. What it means, the change in energy of the system is negative. This means that friction is causing energy to leave the system because friction is a non-conservative force. So energy is leaving the system into the surroundings through heat or thermal energy and sound energy.